in the cloud, and the training process is took a couple of weeks. And you can do the numbers, and you have Microsoft people here, they can help you do the numbers, high processors, high memory, full of this access for a couple of weeks. Tons of money. The other way is doing at home, and you basically put your machines on fire. But for tons of data, you don't need to be that, this is only a specific scenario. But depending on what you need to do, training is very, very complicated. Once you have the model, using the model is very simple.
But for developing, you still do you need like a virtual machine when you develop it, and you fetch the model and stuff?
If you want to do the training by yourself, yes. Depending on how much data you have and how far you want to go, you need to spend a lot of time. But this week they make, I think they make public, I think so. Azure, I can't remember the name. It's basically a system on top of machine learning to help to make the trainer process much more intelligent. It's basically something that came out of Microsoft research, and it's amazing. Basically, puts the training process. Once you start to train your model in each iterations, the training system becomes smart, intelligent to adapt the data that you really need to improve your system. Oh my God, I can't remember the name. I was talking to the Italian guy yesterday. I will share the links later, because if you are deep there, this is going to put a lot of money on training. It's going to help us to reduce the resources that we are using to train the models. Oh my God, I want to say the name and I don't remember. I will get there. Let me do a search on this. So, hey, ABC of what we just did. Define the features, define the labels, train the model, we have the model. In this case is this feature. Once we have this, we create a new input data, we do a prediction, and we have the label, and that's it. And the important thing here is that this is the pipeline. This is what we are going to create if we want to train a model. And once we have this, we started to do this again and again and again, because when you are working in real machine learning projects, you don't use all of your data to train your model. What you are usually doing is you split your data, 80% and 20% or something like this, and you train your model with this 80%, and then you use the other 20% to validate your model, to evaluate your model, to basically get some numbers there like the accuracy of your model. So you know that if you train with this and you evaluate with this, that your model is 80% accurate. So okay, that's fine. You can train again, you can add some changes to get to 85, 80, 90, 95, something like this. So this is what we are doing right now. Defining the pipeline, getting data, and use the model. And of course, once you start to use your model, and you detect some data which is not valid for what you're expecting, you can label this in the right way, going back here, train again, and version 1, version 2, version 3. And this is what we are doing. And what is important here is that machine-learning.net is created for developers, for C# developers. So it's a set of APIs. And right now, in the new version, in the 0.6 that they're going to develop, they are going to release, they are going to change a lot of API to become much more natural. So we are going to type like we were typing with React effects. We're going to have hard-coded classes. We just talk about these kind of things. But at the end, what we have here is a collection of, I can't remember the name, 30 or 50 or something like this, trainer system, learner system, linear trees, whatever, all of these. We have a lot of transforms because we are working with data. Sometimes we need to transform some data, text data to numbers, image to numbers, convert an image from colors to RGB to gray and then to numbers. It's going to be all there. And we have a lot of things here to basically help us to calibrate and adapt the data. Sometimes when you have a lot of data and the data have some specific patterns in the data, you need to apply some math functions there to have correlations. So it's all part of the framework. And of course, it has extensions to connect with CNTK or TensorFlow. I'm going to show you a TensorFlow connection that we have right now. And this is the idea. And internally, machine-learning.net is something that is public right now. It's been up and running for a couple of months for us, but Microsoft have been using this for a long time, but they didn't make it public. So, in example, you know when you are in Excel, and you select some data in a worksheet, and you go for charts, and you have this recommended chart. This is a machine learning model, trained, which basically analyzes the data that you have, the type of data, and the relationship of the data, and it's going to say, hey, this is good for a bar chart, or a pie chart, or a scatter chart. And, depending on the option, is what created using machine learning. The same when you have design ideas, when you, I don't know if you see this, but when you have PowerPoint and you put a picture or draw something, and you enable the design ideas panel, it's going to say, hey, this could be look fine with this layout, or with this layout, or with this layout. So this is all machine learning.net component that have been using internally. I can't remember how they are using in Bing and in Windows. This is something detecting malware, and in Bing I can't remember how they are using this, but this is not a new problem. They have been using this internally, and now they make it public. And other thing which is important, let me go back here later, is that the Mafia or Chihuahua stuff that you see here is not new. This is something that has been up and running for a long time. And the bots are not smart. The bots are not smart. What are these muffins? What muffins? What are the muffins? The Chihuahuas. This is something that we've been dealing for a long, long time. So you need to understand that we are going to do this. I just was talking to a couple of guys here, and I shared with them that all the important thing is, if you need to understand what's happening in the back, go for GitHub, download the code, and you have everything here. It's all open source. So if you want to know which are the trainers available, and you want to understand how the fast true regressor trainer works, if you really want to go there, you can download the code, create a sample, try it, debug it, or whatever, and get it here and use it here. If you want to do something if you want to propose a change or something, go for GitHub, submit a pull request, go for issues, interact with the team. They are amazing, and they are very focused on trying to make this useful. So this is very, very good. And the two main resources here are the GitHub for machine learning and the GitHub for learning, for samples. Let me show you this while I work the other. So this is the machine learning repo, and you can see here you have all of the code here. They are working right now in the next version, 06, which is going to be released in the near future. But you can also go and see the machine learning samples repo. This is another repo that is related, where you can find samples in C# internally working, which are details of the model that they are using, why they choose this trainer instead of the other trainer. So let me show you how this one works. So let's close this. Why am I going to close this? So I'm going to go to samples. I'm going to go to the machine learning samples, to C#, end-to-end, and I'm going to open GitHub later. The idea behind this model, this solution, is that when someone submits a new issue into a repo in GitHub, based on the historic labels associated to it or to other issues that are there, it will automatically add the labels there. So what are they doing is they use this file which has the ID of the issue, the area of the issue, the title and the description, and with this, and it has, this one has, let me see. Visual Studio is not very good to open big text files. So let me open this one. With Notepad++, and this one has over 1,600 something issues, and what the project is doing. Let's debug this. So it starts. Expected that this code is a little more complex, but basically what they are doing is creating a builder, then they build the configuration, and they create a pipeline. They load this text file with this specific class. This class has ID, area, title, and description. This has the structure that we see in the CSV. Then we define the area as the label, the title as the title. We change the title for title, description for description. We can make add one together the features for title and description. Then using the same trainer, we're going to predict the label. So let me do the ABC here, and let's train this. When I am training this, it's going to detect that some of the data inside the CSV has some error because they are not well formatted. When you train, you can add some flags here to say if you detect wrong data, stop or move on and don't read that line, in example. And once I have, and I am going to go back here, this up and running, I am going to write the model. Because the idea here is that you don't need to train. Imagine that you are planning to use this in production. You don't need to train this every time that you use this. You can save the model, and the model is saved here. So let me go back here. So here I have a zip file. This is my model. This is a zip file. This is 1 megabyte model. So this is the model that I can open later, and instead of training the model, I can use it. So the idea here is I have this, and what I can do, I can start to connect to my one repo and do the analysis. So let me create in my, I don't know where it is, I have this one of my repos. I don't have any issue here. Let me create an issue. Let me copy one of the issues from here. I only want to have some text. So I have a new issue, and let me copy another one. This one. So right now, in my repo, I have these two issues. As you can see, they don't have any label here. And what are we going to do right now? Is going to create a label replication, which is going to pick up the owner, the name, a couple of tokens, because I have here using the personal token, and it's going to automatically label all of the issues. So I will avoid this. It's going to have all of the new issues. I should have two elements here. There they are. And then, come on. I am going to do the prediction. I create a new one. And from this issue, which has these elements, ID and can indent, the one that I create, I am going to predict a label for this. And the predicted label is infrastructure. I don't know why, but it's there. I am going to do the same for the other, and that's it. And 5 seconds later, I have my labeling complete. If I go back here to my repo and I reference the repo, you will see that somehow both of them are labeled infrastructure, because this code in the training model they have detects that they are probably go for infrastructure. So if you want to do something like this, automatically pick up some data and do some labeling, categorizing or something like this, with a couple of lines of code, you can do this. And right now, by the way, they're using this in machine learning in their repos. So automatically, when you create a new issue, automatically have the label here. It's very simple, but a powerful scenario. So I was talking about loading and saving models. So I am going to show you right now. From now on, it's all about showing you how this works. So as I said, it doesn't make any sense to train your system every time that you need it, because training is fast here with a small amount of data, and when you're working with big training sets, it takes a lot of time. So what you can do is you can write your model. Again, a simple line, and you write a model. You saw that I write a 1 megabyte file for this. And if you want to use the model, if you want to, once you have your model created, if you want to use it, the way to use this is to load the model. You have a location, you have a prediction model with a sink, you use the data types for the info and the output, and that's it. You can use it every time. If you have an application up and running, a website, an example. By the way, I don't think I say this. This is a .NET Core 2.0 application. That means that you can run this console application Windows, Linux, Mac, whatever platform .NET Core is supported right now. You can run this, you can do all of the things that I'm doing right now in a console app or in a web app. So you can do this line of code.
Do you have to have Visual Studio?
No?
Visual Code, it'll work? VS Code?
If you want to program in Beam, in whatever, .NET Core doesn't require, go for Visual Studio or Visual Studio Code, for sure, but you can do core and compile with command line tools for whatever you want. But my goal here is that you can load this model and do predictions in a website. To train your model, you create your console to train your model. Once you create and train your model and you are confident enough to use this in your website where you really need this, you load your model in memory and start to use it. And you put a file system watcher, and if sometimes, because you train and get a better model, you change this file, drop the model, load the new one, and continue using it. So there are two pieces here, and you can use it anytime. You don't need to train anytime that you plan to do a prediction. And I am only using prediction system right now, there are others, but the idea is that you can read from a file for a selected model and use it. You can even go, and I talk about Onyx. And as I said, Onyx is a standard. What's happening if you want to export to Onyx? Once you have your model, you have a class which is Onyx converter. You define your path, you define the JSON with the output. You need to add a domain because Onyx has some requirements. You convert your model, and then you save your Onyx model. And after this, you have a .onyx file that you can use anywhere. And you can export to anyone supporting Onyx. Is there. So this is all other. There are other scenarios. Yes.
Is there a difference between the zip that you send and this Onyx file, or is it?
The zip. I said this with the zip file because I want to open this. If someone wants, this is what we have internally. Tons of stuff and files and whatever.
Okay.
And this is kind of the machine learning.NET saving format.
Right.
Onyx is a different standard. If I have an Onyx file here, there is a very cool tool called Netrox. Let me see if I have it installed. I think so. It will take some time, but there is a viewer. It's going to open, which open Onyx files, Netron, and it's going to display each one of the steps. Each one of the steps that the model is doing internally to get here, but I can see the input, the output. I see that this one requires for an input an image with this array. I'm sorry. On the output, is an array of 8 float numbers. And by the way, if you know these guys, if you are a C# developer, this name is probably familiar with you. This guy is a very, very smart C#. He created Reflector, he created a lot of tools that sometimes you use, and he created this viewer for Netrox. I'm sorry, for Onyx file called Netrox. It's free, and it will show you each one of the steps that this Onyx file is doing to analyze a picture. This one is for emotion recognition, yes, to analyze a picture. And going back here, not here. I save it with .zip just because I go for .zip, but it's the machine learning standard. You can save it with the extension that you want, and if you want to export this to Onyx, you can do this from here. Also, there is a set of tools here in Visual Studio which are called the AI tool, artificial intelligence tools, which allows you to do this. You can convert a model from Core ML or to TensorFlow to Onyx, and you pick up one model, the other, a couple of options here, go for OK, cross your fingers, spends a lot of time. Maybe you are lucky and it works. It takes some time, but hey, in machinelearning.net, you can also export your model to Onyx. If you want to use your model later in an iOS application here, export to Onyx, export to Core ML, and use it here. The latest scenario that I want to share with you, this one, which is basically the sentiment data that we have. What I am going to do here is I am trained a model. I'm sorry, I don't want to do this right now. Okay, stop. I am going to train a model, but before doing this, let me show you what I have here. So, sorry. So I have, for train, I have a lot of data from EMDB, and basically what I have here is a comment, and I have 0 for good comments and 1 for bad comments. That's it. And I have here 1,000 rows of data. And to test my model, to see if it's working or not, I have a similar set of data from GEL, which is, again, text and rating, text and rating. And from here, I also have 1,000 models. So the way that this one is working is, I am going to train a model. The train is the ABC of what we see. I create a pipeline. I define my sentiment data. The sentiment data here is very, very simple. It only has sentiment and label, two columns. Then I'm going to say that sentiment text is my main feature. I am going to use a different trainer here, fast tree binary, and this is a specific configuration that I can add here. If someone wants, or we can speak later, what are these numbers. And then I will say, I will train the model, and when I have my model trained, I will evaluate my model data. And evaluate the model is not my model. I'm sorry. And when I evaluate the model, what I am doing basically, I load my test data, the GEL data, and I create an evaluator, and I evaluate my original model with this data, and I have a couple of functions here, a couple of values, which are the ones that we use in machine learning to say the accuracy of the model, F1 score of the model, is basically analyze how many false positives. I don't want to go to the details, but here what we have is which is the accuracy of my model. So let me do this in example in a very quick way, so you can take a look at the standard training, how it works. So, and you see that there is a lot of commented code here, and you are going to see why. ABC of what we have here. Train model, learning pipeline, can load my text, have my features. If I open the pipeline here, I have everything here in the bottom. I will load the trainer. I will train my model. I have the model trained. I'm going to load my test data, and I will going to have this value. So using the standard training, the factory that I have here, the standard training model, I have a 66.6 percentage of accuracy, which is good or not good when if I add and try with the new tweets here and it says it's good or bad, I am going to be sure that 66% of the tweets and the analyzed tweets are going to be good. But what's happening if I want to do something different? What's happening if I want to improve my system? So I can start to check. I can start to try different models, other models. Oh my god, I have so many code. Other models, other trainers. I'm sorry. And what we can do right now, we can use what is called word embeddings. And let me show you what is this. So word embeddings. Once I train my system, and because this is for sentiment analysis, there are a lot of people working on sentiment analysis in English, and they created amazing models here that we can reuse, that we can go and train and reuse, and they already have a full set of data training with text good, text bad, so we can reuse this. And the only thing that I need to do here is I can add a word embedding, and I can say that, hey, this is a new feature. It's going to call feature B, add it to the feature A, which is my sentiment text, and train the system. If I use this by default, I'm going to show you both. It's going to take some time. Okay. Training 1, training 2. So it's downloaded this file from sentiment aka.ms, one of the word embedding from here. So it's downloaded, I think it's a lot of file. This is 700 megas there. So it will take some time. And with this is going to train the system. So this training is going to take some time. And the second model, this is the standard one without word embedding, 66. The other one is 72.4. So I improve my model. This is the type of thing that we spend a lot of time trying to figure out what I can do to have a better accuracy, for example. I can improve my model. If I go for a different example, like an example when I create my word embedded model, I have the options to train the samples using word embedding with all of these pre-trained models. Fast text Wikipedia, blog 100D, blog 500D, blog Twitter. Some of these models are 6 gigabytes of training data. So I can't remember which one of these. But if I enable one of these, it's going to take basically maybe 5 minutes, or I don't know the speed of internet here, downloading the model, and then we are going to go back and come back for the next session, and my crappy surface is going to be still trying to train this model. Because with 6 gigabytes of data, it's trying to understand what's happening. I think the first one, let me double check, is good enough to show you the difference. So I will run this again without using 3 model standard word embeddings and word embedding but one specific flavor. And the second one is already downloaded, so it's not going to go there. And then it's downloading this one, 170 megabytes or something like this. So it's going to take some time, but I am downloading this TXT file here to train my system. There are a lot of things that you can do right now. And this is part of you were asking, if I have this scenario, what I need to use. This is the thing that these guys are working right now, trying to figure out 80% of the requests that they are having is focused on sentiment analysis of text. So they created this extension to do this. Other scenarios are trying to use these very popular trainers, like BMG. So they created a wrapper around like BMG. And all of these are the ones that they are created. So we are almost there. It's 100 megabytes. We still have 70, a little less, let's say 50 megabytes to the low ones.
So at this point, I guess a lot of trial and error, right? Trying to find the right
Try now.
imputation.
Yes. You need to have a very powerful machine, not the demo machine, to do this kind of thing, because this is already here. Then the next scenario I'm going to show is going to be just the last one. So you don't download the external files to do the training. And then it starts to train. Training is very fast. And using this specific model, my accuracy is not good. I still go for this one. If I need to use this or this model, I will use this one. Still better. I can train and get it there. But this is one of the things that the machine learning.net team is working on, trying to figure out which are the scenarios, the most requested scenario to figure out, to help us to use it. The other more requested feature was there are a lot of models created with TensorFlow. How we can reuse this model? And when you create, as I said, TensorFlow is kind of the most popular one. It has a huge community behind this. It has a lot of people working. So in the latest version, it's not in this one, in the beta version, we have the chance to use, let me go for samples, let me go for C#, more samples, to use a frozen TensorFlow model already created to analyze images and doing a very complicated and crappy set of lines of code. This is not elegant code at all, sorry about that. You can use a TensorFlow model. So the idea is that if you are, as a machine learning developer, as a C# developer, working with people who are using TensorFlow, we can pick up these TensorFlow models and basically doing all of the Onyx things that are in the back that we don't know how they are working, we can use this. So here we are using a model which is called the Cypher Model. Let me open here in my assets folder. We have this inception graph model, which is basically using an ImageNet to analyze image, and it has some data classification. It has some data classification model, so it's going to analyze all of these pictures, and it's going to, yes, I know, and it's going to give me the label for this. And the way that this is working is like this. I have all of my background, all of the background work is already there. It's loading classes. Oh, I'm sorry, I forget to add. Okay, so what we have here, again, a pipeline, loading a TSV of data, loading a image loader, which is going to basically allows me to load images. This is a class, this is a tool that we have inside of machine learning.net, which is smart enough to load an image and convert the image to an array of bytes. Then I am going to resize the image because this model works with the image in this size, and I have this. So the image resizer is going to do the resize step for me. Then I have my pixel extractor, which is going to basically do some specific conversion that I need to do in the image to be used in this model. And it has everything here again. And then I am going to use a TensorFlow store, which is a model smart enough created in TensorFlow to do this model, to do this image analysis. I add my features column. I convert this label data into text using a standard classifier. I have my pipeline. I will train my pipeline. This will take some time.
What feature were you going for there in those pictures? What kind of conclusion are you making from the picture?
I am trying to figure out that this is a teddy bear, this is a banana, and this is a broccoli, which is very simple for us, and it's requiring 200 lines of code here. So once I have my model is trained, I think so, let me go another line, still there, still training. I hope I didn't open the, oh, there it is. So this is my model, it's already trained. And what I'm going to do now is I'm going to do my predictions, which is basically try to get my labels. This is the labels that the model are supporting: broccoli, buckets, canolas, and teddy. I will read my test data, which is an image. This is the location of an image and the expected label that I want. And for each one of these, I am going to do a prediction. So for the first one, let me run F5. The broccoli.gap is a broccoli. That's amazing. This is the most complicated demo that you have created. So basically rename your picture with hat. But the important thing here is that we are using this.
Was the file name part of your input?
No. No. Let me show you that this is not calculated. You get the point there. Image, broccoli. Let's try it. This one, in the plate. It's going to be complicated. Okay. Oh, where it is.
In the soup.
Okay. Copy mesh. Let me open info view. Go to the image folder. My cool broccoli. Broccoli is like this. My cool vegetable. I don't want transparent color. So here it is. My cool vegetable. It is PNG. I don't know if PNG is supported. The next thing I need to do is go here and set. Just in case, let me do this.
You got a PNG up? Oh, yeah.
Yes, I will convert this because I don't know if I support GIP. So here it is, my GMP file. This is what I'm expecting, broccoli for my cool vegetable. And if I go back here, let me double check that I have everything, both of them. So let's run it again.
So now you're using the model you built in the first run, is that right?
No, it's going to train again the model. I mean, the way that it's supposed to do it, yes, it's supposed. Oh, I think I have opened the file. Or maybe yes, or maybe the image is not in the correct format. Again. I need to double check here what is happening, but
You have one more image than stuff in the list, so it probably doesn't match up.
yes, the options here are, or I basically, it doesn't support space, which is probably
Sure.
option A, that is not working, or my GSP is not in the format. We can spend some time on working, but what I am, the important thing, the main message here is that we can use TensorFlow models here, which is huge. I'm sorry, not this one. We can use this model, which is huge, because this one is going to be open again with Newton. This is something created with TensorFlow. Yes, I know. Later. It's created with TensorFlow. It's similar to Onyx. We can use it here, and this is something that we can pick up. If you have a marketplace with Onyx model, if you go to TensorFlow model, there are thousands of models. So you don't need to create your models. Probably someone else already created for you, and you can use it. I think I'm already there. Let me double check my slides. I think that I have, yes, open source, saving and loading model. What we have in the future, next version is going to basically change all of the API that we already know. They can do this. This is not a major version, so everything that you wrote, you need to write it again. If you have something there, the developers are happy about this. They are going to add, as we were talking before, the scenarios, guidance for scenarios, basically saying that if you need to do A, B, and C, the suggested trainers, the suggested sample scenarios are 1, 2, and 3, so you know what to do. This is very important. Right now, the tool is mature enough. Let's work on the documentation so we can help us. Deep learning in the next step. I will add a deep learning session when machine learning.net is mature enough if you want to see what we can do, but this is the next step for machine learning.net. Support the same features that we support right now with TensorFlow CNDK for deep learning, and a lot of other things. We already have this one. Scale out on Azure is already there. They are planning to create a visual tool to do these steps, so you don't even need to code. To say, I want to create a pipeline, I want to add this data, this is my features, this is my column, this is my labels, I want to train my system, do it, and that's it. And it needs to be fully integrated in AI. So this is basically the scene that you have right now. Before going there, there is this session from Build that they cover machine learning.net, and these two guys are part of the product team. I am going to share the link of the session if you want to go there. They also talk about the first version of the GitHub labeler. This is another way that you can also see what are they doing, and this is a very good one if you want to have some other point of view. So that's it. If you have any questions, that's the moment. That's me. I am going to post the code and all of the samples tomorrow or Friday in my blog, bruno.com. You can contact me via Twitter. Bruno, thank you very much. Yes.
A question. So Google's TensorFlow advantages you can run on their TPU tensor processor unit. That's custom designed for fast execution of machine learning tasks.
Yes.
So how what's the Microsoft solution to that? Do they have in the cloud the same speed like Google TensorFlow TPU unit?
I can't remember what is the line of the public and private information here, but yes, they have something similar. That's the answer. Everything that you're seeing right now that they're using in WinML for Windows 10, they are basically getting deep into make this as advanced as possible. And by the way, the full strategy here from Microsoft is not to compete with TensorFlow community, because the TensorFlow community is huge, so it doesn't make sense to compete. Let's try to use all of this, the stuff that are already there, all of the knowledge, and have it here. But they have something similar. They have a couple of virtual machines in Azure fully dedicated to do machine learning. We have a specific set of resources. CNTK has a custom version focused on these kind of scenarios. So I don't know if it's public or not, but there is something similar to TPU somewhere there.
That means you can build your application ML in Windows and then migrate to TensorFlow execute on the TPU.
What you can do is you can create everything but the train in Windows, and then using Onyx, convert this to TensorFlow and train wherever you want. And the output model, use it whenever you want. So that's also the idea of Onyx. Give you that flexible. If you are a C# developer, do everything but the train, because by the way, I didn't show it here, but when I say train, it's doing the train in my local machine. But there are going to be a couple of features in the future where you're going to say train on Azure, something like this, train on the cloud. With a couple of parameters, everything that you define it is going to be trained here, there, maybe including TPUs, Amazon, whatever service that they have.
Because right now TPUs, they evolved like, I think it's version 3 or something that has like
I know,
amazing speed in execution.
Yes, I know the basic of TPU. I am not deep there, so I don't know versions. I don't know what they do, and that's basically it. But yes, as I said, they are not with this. Machine learning.net is not to compete with this. Is to C# developers to have the chance to get into machine learning, basically in a very fast mode, without learning all of this obviously. Because if you want to do something with TPU, you're going to probably spend a couple of days only doing configuration, only trying to connect all of the dots, that everything works, which is not easy sometimes. Oh, yes.
I was wondering if you, when you're training your model and you said that you can save your model and pick it up later to use it, is it possible in general to train a model and then provide more data to train, to like add to the model?
Yes.
Without retraining all of the previous data that you trained into it?
Yes, right now it's not available in this version of machine learning.net, but to do this kind of reinforcement learning, you can do this. You basically train with all of this data, and when you have all of this data, you don't want to train again with all of this, you train by chunks, but this is going to be in the future version, because this is very simple scenarios that I am showing right now. When you work with huge set of data, maybe you are going to spend a lot of money training in hard work. Other question? Oh,
All right. Thank you, Bruno.
thank you.
That's a great start to our season. I want to thank you all for coming out tonight. Feel free to reach out anytime through the meetup group. You can send me a message if you have any ideas or recommendations on sessions you'd like to see or topics you'd like to see us bring to you, because I like to tailor it to what everyone wants to see. I don't just pick the things that I want to talk about. Definitely what is more popular for the group and what you want to learn. I'm all about bringing those sessions to you. Please submit topics for lightning rounds. Love to see a lot of you get your feet wet in speaking and doing a topic like that. And then I know also in October, Microsoft has a thing called that they're participating in called Hacktoberfest. So if you submit a pull request against any of the Microsoft open source libraries, they'll send you a t-shirt. So I'll post the link for that for more details on the meetup page as well. Please add your comments to the meetup page for this session. Let us know what you thought of this session, things you liked, things that you think that we could improve on. And once Bruno makes the information available as far as the code and the deck, I'll post a link there, or he'll post a link there as well under the comments section. So with that, have a good night. Thank you, and I hope to see you next month.
Thank you.
Thank you.